my name is Alexis Torres, and this is my final project for EEC 10. Before I explain anything, I'd like to thank Professor Chua and the TAs Wakaz and Scott for their help. So basically what I have here is a VI that is like the user interface right here. This section right here, this is a timed recording. So basically you set like whatever time you want it to start, kind of like an oven in the kitchen. And once it hits that like time, comparing it to the time of the computer, it'll start the recording for however long you want it. And here you can set the duration and the specific time that you want it to start at. And over here, this is kind of like a sound localization thing using a filter. This all goes through the microphones, it gathers the data, sends it to the MyDAC, and then the microcontroller then moves the servo to wherever the sound is located at. So first I'll show you the timed recording. You can do this by setting the time. This is like a function that we found in LabVIEW. So let's say we'll set it to like 30 seconds later. Here you can start the VI. Here you can see that the current time is running, showing you how long it'll take for the recording to begin. So once the recording begins, you'll see the green light come on. That indicates that it's recording. So once you see that, like now that it's started, we can see that the graph is showing the different like waveforms. And if I snap, you should see bigger wave. Or if I snap on the other side, it should also show a wave of a different color because this is a 2-channel stereo recording. So now that the finished recording is done, we can go to the desktop, and it's the most recent file. So here we can play it. See that, like now that it started, we can see that the graph is showing the different like waveforms. And if I snap, you should see bigger wave. Or if I snap on the other side. So yeah, that's the recording pretty much, and it goes for like whatever time you desire. So if we open up the other part, this button right here basically just lets you switch between the two functions. So here we have the like the main frequency that you want and the bandwidth. So that pretty much is set by the user, and this will only like move to frequencies that are within that bandwidth. This just shows you the amplitude of the sound waves. And basically how this works is it takes the amplitudes from the two microphones and it compares them. Then once it gets the difference, it pretty much calculates like which one is closest to the sound. And then with Energia, it sends that data through the microcontroller, and that tells it like where to go. So let me just generate a sound frequency with the phone right here. So now we can hear this tone, and if I press start, it should start moving to wherever the sound is. So here we can see, since the sound is on this side, the servo motor begins to move towards the sound. Or if I move it over here, it also moves that way. Over here in the graph, we can see that depending on which side you're on, it shows you which color is bigger. So yeah, basically that just shows you where the sound is at. And the key to this is having like enough distance between the two microphones so that it can like differentiate between the two. Yeah, just like depending on the space where it's at. And yeah, that's pretty much the project. Hope you guys like it, and thank you.